Okay, welcome back. So this time it's not a direct calculation using the trapezoidal rule. We don't just get area from using substitution of values. This time the value we're looking for is buried inside in the formula, somewhat intractably, but not completely, because we will be able to extract the value as we come to it, and that is its actually its relevant position, where that would end up. Okay, so what we're going to do is to do straightforward substitution and then just follow BIMDAS until we end up with x. Okay, so straightforward substitution suggests that we would start off with 1540 for the area. The height would be 10 over 2. Now I will just point out something, and this is from bitter experience. There's two 2's here, and just be careful about how they process. And I will confess that I have made mistakes and dropped that 2, because it turns out there's 32 and a 32, which you double. And that you can let your guard down and think you've done your doubling now, but that's a completely different doubling than this one. If you made that mistake, and take some reassurance that teachers make that mistake too. I did. And this is a retake video, by the way. So just to let you know, I decided not to. I'm sure you'd love to see me struggling with it, but I'm just showing you the real thing, or at least I'm showing you a polished version, somewhat. But at least I'm honest. Okay, so so we move on in here, and we will just try and make these things stay beautiful. So we'll not have a whole harlequin of colors, 32 and 32, and double. And we're doubling into certain values which we lift from the data, which is 26, 29, 30, and 24. Notice I took the values and I rearranged the x out to the end, because that's called applying the principle of commutation for addition. Of course I can do that. Now, this is where I want to keep track very closely. So with BIMDAS, there's an order of operations, and when solving equations, we go through BIMDAS backwards. So multiplication is the most, we don't get up to powering. There are brackets, but so I just wanted to justify, even though there are brackets, we can still jump. We can still skip the index pit and jump into this because this is all a factor. So I'm going to put the 2 up here and get 38. And I'm going to divide the 10 in. Now I'm at 308, and it shouldn't be smooth. It's step by step, but now I can do this. You only discover after doing this calculation that the 10 divides in. Now here comes the treachery of the double bit, so you want to be careful of. It's 64, you've done some doubling here, but do not forget this 2. And as I said in an earlier confession or cool caveat, I did. And what I'm saying that is because I want you to know that problem solving is not smooth, and you need to be on guard, and it was only critical thinking that allowed me to find that I had made that mistake. I think because of this x, the best thing I do now is just cherry pick into this particular calculation. You know, you've probably heard of friends of 10, so that's a friends of 50, and then we have 59. So I can see quite clearly that's 109, but certainly, and I have to be sure there's 0 risk on that. Otherwise, I have to go to the tables, and then I have to be very, very careful here. So I have to be honest and say there's an x still lingering inside the bracket there. Okay, now again, BIMDAS would suggest that I subtract 64 next. So you don't wait. Often I say please wait until the end before you use your calculator, but in this case it's hard to justify that. Okay, because what we want to do is pick bits and pieces off the numerical problem as we go. So there's my subtraction done. Then I'm thinking I should do the division of the 2, which is that 2. So I've subtracted that 64 and I've divided by 2. So what I have on my calculator now is 109 plus x. Is that logically sensible? Because we know x would want to be positive. Yes, it is. So we subtract 109 from the 122. And it's 13. Okay, x equals 13. Then we check for units. Should be part of your algorithm. Don't leave your hair down, your hair down. Say I can relax now. Do that. Box it up for the examiner. Next question. Okay, at first this looks very, very tedious, but it's actually not too bad once we look at it. So once we read the question, which we're going to do now. Diagram Ops shows a scale drawing of a diagram. And that was a major theme of your junior cert exam if you did it. Okay, so the whole idea of having one thing scaled from another. So the scale factor will be in length, and then the area will have a scale factor in of the square of the scale factor, k and k squared. The side of each small square represents 5. That's one of these little babies here. Using the trapezoidal rule, which h equals, is that 2.5? 25 meters, I presume. Estimate the area of the field. So they say, basically what they're saying is use 5 boxes. Now I'm kind of struggling with this, but the way I look at it is, and for fine work, you know, I might just create a pencil here and make that pencil particularly fine. Okay, so basically that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and each one of them is 25. Okay, and then we can count in 25s, 1 and 2, that's 50. 0 here. 1, 2, 3 is 75. This is tricky. 50 and 12.5. 62.5. And I'm going to stagger up and down so that I keep getting to do my writing. So with this one, 1, 2, 3, and 12.5, 75, 87.5. You can certainly. At first, I'm not too sure whether I should be doing so much work and whether I possibly made a mistake. And that's another thing. Doubt can creep in during problem solving. And I just say to you, if you're yes, do doubt and do consider, but then if you're do consider partial credit and everything else, and I might probably be on the right track, but it just does seem to be there's another very intractable question. 1, 2, 3, 4. That's easy. That's 100, and we've gone up again to 125 here, and we've come down to 112.5. Now, some people like to just put this data into the calculator because there's so much work in processing it, they think, why process it twice? From a partial credit point of view, I'd suggest not doing that. Yeah, and so 1, 2, 3, that's 75, and then remember this is not, the end here is 1 3/4, so that's nasty again. So well, each box of course is worth 5, so I can do it that way. 1, 2, 3, 15, 15 and 25, 40. That's a tricky one. 40. Okay, so we're going to take the formula. It should be coming through now, but the formula hasn't come through yet. Doesn't matter. I do know the formula. I hope we know the formula. Okay, so the area is approximately equal to, now there's an approximate, well, due to the curviness, if we read it properly or with enough precision, the only approximation comes from using the trapezoidal rule. But one way or the other, we get 25 over 2. A reason I'm saying that is there's also a possibility, this is a type of measuring, and unless we can see it with enough precision to see where the dots are, there is also a sense of inaccuracy due to the fact that we're measuring or eyeballing and figuring out where things might be, because that's the nature of measurement, and that's what separates physics from maths. 25 over 2. The first and the last, well, the first is 0, and I'm writing it in, as I say, to keep the shape of your formula. Otherwise you go into unfamiliar territory that you don't need to go into. So here we go. Now at this stage, there's no way I'm writing out those numbers again. Okay, so we're going to keep those numbers, and just to say the 40 and the 0 have to be in some manner separated out. Okay, so it's really it is important to take out the calculator early and start subbing. So as I've always been saying, always run with the fraction, and this is an example of where you want that fraction bar, and let the calculator do the work. So even if at the top is even, get into the habit of always leaving the fraction bar there. Just for the hell of it, I'm going to put in that naught plus the 40, just because it's not going to do any harm. Plus double and this fraction bar, this open a bracket. And now I'm going to place, and you do the same, place your calculator down next to your graph. Okay, I'm doing it in softly on software, but you do the exact same on a piece of paper. Now we're going to go 50, 75, and so on. So here we go, 50 and 75. This is the time to be careful on getting the numbers in, but also take a little bit of a mental rest and trust your calculator for everything else. 62.5, 80, maybe mark them off as you go. Well, I'm not going to, because you can just see why. 87.5 plus 87.5. At least you don't have to worry about pluses and minuses in this one. And plus 100. Plus 125. Down to 112.5. What's that 75 down there? Yeah, it's over there. Down to 112.5. Now, notice that I kind of criticized myself and I was going, where's that 75 coming from? And next time, I want to maybe not keep him so much to the left, you know, but I have figured out my own. It's like somebody who can't read their own writing or something, you know, can't read their own maths. Now, do I need two brackets or not? I'm pretty sure I do, and that's another reason why maybe not to break convention and do mental maths, especially here when you can't see all the way back. Now, you can keep clicking here and go all the way back, or better still, because that took ages, you can go around the house, as I sometimes call it, by saying I run to the end and keep going, and you end up back here and check, did I use all the brackets? Because I could have possibly, well, in this case I don't think I could. Anyway, come on, we did equals, and I'll stop boring you. We'll get on with it. We get 17687. 17687 meters squared. Now that's quite long, and that, so I'm just going to have a quick look at the website that I've set up for you, and see do the same answer there. It's LCM34, to the best of my ability, is the final part of the website address. It's a Padlet. Just remember 34, because that's the part of the syllabus you're studying at the moment. And I have all these questions, and hopefully links will be going in there for this video. And I have the answers. It just makes life a little bit handy. 17450, 17450. Well, I'm not too sure. I'm happy enough with that. I presume in a case like this, they got 17450 meters squared. I'm definitely not looking over that. That'll do. And question 6, but you'd only want 5 for homework, so I'll drop it. I'll stop it at the video at that.